So this is a conventional keyless chuck that you've probably used hundreds or even maybe thousands of times in your life. This, however, is a new style of self-tightening keyless chuck that can be used for drilling and for tapping. It's got some type of fancy gear type of tightening design inside, and in today's video we are going to test it out. I'm going to measure the runout, I'm going to do some drilling, some tapping, and we're going to try and notice during the video if it is easy to tighten and to loosen, and also if the bit slips during any of the operations. So these conventional keyless chucks all work in a very similar way. It's an age-old, proven and reliable design. I think it was actually originally invented by Albrecht in Germany in like the 1930s, so that's almost 90 or 100 years old. It's pretty damn old, and it uses a threaded spindle in the middle of the chuck to drive out the little jaws and to grip onto your bit. And the threaded spindle also retracts the jaws. So that is a proven and age-old design. This new design of chuck, though, uses an internal gear and threaded mechanism, and it's also got a ratchet inside. Now, I'm going to say supposedly because I haven't actually stripped this chuck to see what is inside, but it has definitely got a ratchet. You can hear that. And I have seen some video animations of the internal workings of this new design of chuck. So I'll leave a link to that in the description. So the question is, how did I get my hands on it and where does it come from? Well, in a previous video where I reviewed this keyless chuck, a company by the name of FODBITS, I hope I'm saying that correctly, they left a comment there. You can actually still go and see it on that video. And they asked if I would be interested in having a look at one of their chucks. And after they contacted me, they said that their chuck is easy to loosen and tighten. It can be used for drilling and for tapping, and the bits don't slip in the chuck. So I thought to myself, well, look, this sounds interesting. Send it, let's have a look. So I ended up asking for this specific model. It's a 1 to 13 millimeter chuck with a B16 female receiver in the top of the chuck. Now I asked for this specifically so that we could stick in an MT2 to B16 arbor, but you can also use it with a torque adjustable drilling arbor. I can also stick that into the top of this chuck, and basically what that allows us to do is to set a certain torque on this unit, and then if your drill bit or if your tap jams up, then the chuck will actually start slipping and it won't snap the chuck, it won't snap the tap or the drill bit. Or in theory, at least, that's one of the uses. However, they do make a multitude of other products. I did have a look at their catalog, so you can buy this chuck with like a built-in arbor. It's got like, there's a whole lot of actual stuff that is in their catalog. I'll leave a link to that PDF document in the description. You're welcome to go and check it out if you want to. Full disclosure here, I'm by no means endorsing this company or any of their products. They haven't paid me to make this video, but they did send this chuck to me free of charge, so please keep that in mind. Is it going to affect my opinion of the product? Absolutely not. I'm going to let the testing talk for itself. You guys can make up your decision according to what you see. The important thing to me is that you guys have an independent look at these products, and then you can make an informed decision if it is something that you're ever going to go out to buy. Look, I do hope the product works out for this company. You know, it looks very interesting. But let's see what the testing reveals. Now, another two things is that I said that the company will absolutely have no say in the production of this video, and they will also only get to see it once it is published to you guys, to the public, so that there is full transparency. So the first thing that I'm going to test is the runout of this chuck. Now, this is brand new. It's never been used before, and I'm using it with an MT2 to B16 arbor. They also sent this arbor to me, and we'll test the runout by putting the chuck or installing the chuck into the spindle on the drill press, and then we'll measure the runout. I've got the belts disconnected at the top of the drill press to make it easier to turn the drill or to turn the spindle so that we can see what's happening in kind of slow motion. And the test equipment that I'm going to be using today is a Mitutoyo test indicator and a Noga magnetic base. Hopefully you guys can see the model numbers of that if you are interested. I do also have videos of these from a few years ago. They are on the channel. I'll put those links to those videos in the description. I'll also put links to these products if you want to buy them in the description. They are Amazon links. It doesn't cost you anymore if you use the link, but it just means I get a small commission. And if you want to support that channel, I would really appreciate it if you do use those links. It literally keeps the lights on and the food on our table. So thank you very much to all of you that have already been supporting the channel. It really means a lot to me, and I really do appreciate it. What we are going to use to measure today are a couple of precision ground dowel pins. I'm just going to try and put them up here without dropping them, and I'm also going to use a 6mm carbide, brand new carbide drill bit. The reason I'm using this drill bit is because I want to measure the full range of or the full clamping range of the chuck. So we'll start at 12mm, move down to 10, then move down to 6, and then move down to 3. I don't have a 6mm unused dowel pin. Now, this might not be 100% the correct way or the most accurate way of indicating the spindle, but it's the way that I'm going to do it today. It's all that I've got on hand at the moment. Maybe a better option would have been to get an MT2 to parallel taper arbor, pop that in there and then indicate off the arbor. But I did inquire about one of those. It would have taken a couple of extra days and I had to order it from another city. So this is what we're going to, or this is how we're going to measure it today. So I've just used the fine adjust on the Noga magnetic base to zero the needle. And if I rotate the spindle slowly, we can see that we are starting off with a runout of, looks like 0.01 millimeters. 0.01 millimeters. So just keep that in mind for all of our future measurements. I'll also remove the arbor from the chuck to take a measurement of the arbor by itself. And first towards the center of the B16 taper, and then the second measurement at the end of the taper. And we can see that the dial is indicating almost no runout. And if I move it to the end of the taper, we can see the runout is 0.05 millimeters. Now, each of these graduations is 0.01 millimeters, or about 0.4 thou. Okay, so if I just do that, that should be seated, or somewhat seated. And what I'm going to do here also, I'm just going to press the chuck in just to make sure that it is seated firmly and that it's not going to fall out while we're doing our tests. That wouldn't be great. Okay, and the first thing that we're going to chuck up is our 12mm dowel pin. Might look a little bit awkward, but I'm trying not to block the camera's view so that you guys can see exactly what is happening. So we've got that chucked up, and I'm also going to get this little indicator set up here. Now I do have to be a little bit careful. I need to set it up in the middle of the dowel pin and get the angle correct on the probe. So that should be correct. So if we slowly rotate the spindle, we can see we are getting, wow, not even 0.02 millimeters of runout, 0.015. So that is pretty good. However, what I am going to do is I'm going to take off or take out this little dowel pin, take it loose, and we're going to turn it around just to make sure, you know, kind of for consistency here. So we turn that around, put it back in, and see what happens. And I'll do that with each one of the dowel pins that we measure. Okay, let's get it back into the center of our dowel pin and also get the angle right again on the probe. Now, if it doesn't look 100% correct on the close-up camera, it's probably going to be due to where the lenses are relative to where you're looking at, error of parallax. Sorry, wrong one. Dial is at the top. Just using the fine adjust again to set 0. And then find our low point. Oh, there was our low point there already. Okay, so if we rotate it, we're getting now 0.03 millimeters of runout. And that's if I flip the 12 millimeter dial upside down. So starting off at 0, looks like we are measuring 0.08 millimeters of runout. Okay, quite a lot different to the 12 millimeter. Let's flip this Let's flip this dowel around. And let's see if we get a similar result. Again, in the center of the pin, just making sure the angle is correct. Using the fine adjust to get the needle to 0. Let's look for our low spot. Oh, we might have been at the low spot already. Okay, so it looks like our runout is 0.06. So that's fairly consistent by flipping the dowel pin over, 0.06. So starting off with 0, and we've got 0.06 millimeters of runout again. Okay. Now, of course, I can't flip this drill bit around, but what we can do is I can take it out or loosen it. And you can see there's a little notch, but I'll turn that, let's say I'll turn it 90 degrees, put it back in, and just tighten it up there. And then set this guy up again. That looks good. And let's see if we get the same reading. Yeah, pretty much the same, 0.055. We'll just zero the needle again. And what are we measuring here? So with the 3 millimeter shaft, we're measuring just on the 0.07 millimeters of runout. Okay. One last test. Let's take this 3 mil dowel pin out and we'll flip it over. And then we'll pop it back in. There we go, that's in the center. Get the angle right here. Let's try and find the low spot. Oh, I think we are already at the low spot there. And I'm measuring, once again, 0.07, so it's fairly consistent. Okay, so there we have it. It's you know, just there on just over the maximum amount that they claim in on the specs of this chuck. However, please keep this in mind. We started with a 0.1 or 0.01 millimeter run out here at the spindle, and the further away you get to the spindle or from the spindle, the more the error compounds. So this could very well be just under 0.05 millimeters or even less. And for reference, this is the same pin that I used in a previous keyless chuck review video where I measured the runouts. And this time with this FODBITS keyless chuck, I'm getting 0.05 millimeters of runout. Maybe in another video I will chuck this up with a different arbor. We'll put it into a collet chuck, into something that's a little bit more accurate, and then we'll take some measurements from there. But as things go, for a drill press, this is way more accurate than what you need. It's definitely good enough. If you need something more accurate than this, you're likely going to be using collet chucks anyway. So just keep that in mind. The drilling capacity of this chuck is 20 millimeters. I'm going to drill an 18 millimeter hole. So unfortunately I don't have a 20 millimeter drill bit on hand, but 18 should get us very close to that. There we go, we can see it's 18, pretty much 18 on the dot. So I'm not using excessive force, I'm just going to take it like that and that's it. It can't go any more on the ratchet. And then let's try and mark it here. Mark it there. Sorry, I'm just going to have to come in front of the camera here quickly. There we go. I don't know if you guys can see that. Yeah, you should be able to. And let's see how well this works. And there we go, we are through. So just to note you, what I've just done, this is not very good practice at all. I didn't want to stop. I wanted to put the drill bit under a lot of pressure to see if we could actually get it to slip and to lock up. And I think you did just see that the belts at the top slipped and the chuck actually stopped. So don't do what I just did. If you look at it from the bottom, you can see that our mark hasn't moved, or the drill bit, even though the drill press locked up and everything jammed up, the bit didn't slip in the chuck. So far that's very good. I'm pretty happy with that. The next thing is how tight or how difficult is this going to be to loosen up. So let's see if I can just literally just use my fingers, because you know, sometimes these self-tightening keyless chucks can get really tight, especially kind of the cheaper ones that you get on the market. Okay, so I will have to hold the top. Let me just hold the top with this hand. Yeah, it is fairly tight. It's because I'm trying to grip it, that's why. Come on, Grant. So releasing it is turning it that way. Jeez, look at that. Very, very easy to loosen. And I mean, as you can see, the drill bit just popped right out. Straight through the 15 millimeter mild steel piece with absolutely no problem at all. Now this is a 20 millimeter drill bit, and according to the catalog, it's the maximum drilling capacity of this model of chuck. And the piece of stock that I've got in the lathe is just a normal mild steel piece with a 10.5 millimeter hole already drilled all the way through. And if I recall correctly, I drilled this at 175 RPM. So while I'm drilling here, watch the drill bit for any slippage and also the chuck for any tightening. So how difficult is the chuck to loosen now? And you can see using just 2 fingers, I'm able to loosen it and remove the bit. And this time, after increasing the feed rate just a little bit more, once again we can see a small slip and a small tighten, and then no problems after that. So for the tapping test, I've got an M8 tap here. This tap is also not brand new. It has already tapped 106 holes, although it's still very sharp. And through the same piece of 15mm thick mild steel here, I've drilled a 6.8mm hole, and we can see the drill bit passes all the way through that. And we're going to do the same thing. I'll chuck this this tap up here into the chuck, and then we will try and power tap the hole, and then we're going to see what happens. And that's it, end of the ratchet. And let's pop a little bit of tap magic on you. You're making a right mess. Again, I'm just going to mark this over there. Well, this thing doesn't want to mark now. There we go, and I'll put a mark here on the drill press. Hopefully it is somewhat in line. Actually, looking at the viewfinder again, it looks like it is not in line from where you guys are looking, but from where I am, it is perfectly in line. Anyway, we can see that the tap here is between the two jaws. So if it turns, we should be able to see. So let's give it a go. Okay, now bear with me, this is a little bit slow. It's not the fastest power tapping setup. So far it doesn't look like the tap is slipping in the chuck, which is good news, but again, this is only an M8 tap, and the maximum capacity of the chuck according to the catalog is M16, which is a lot more torque to tap a whole M16 compared to this M8 tap. There we go, it looked like it did slip. Nope, it didn't. It's just looks funny from where I'm standing here. And I think we are all the way through. I can hear the drive motor unloading. Yep, that is definitely all the way through that piece of mild steel now. So let's just go ahead and reverse the action. That tap will now come out, and as we could see, there was absolutely no problem sort of the chuck gripping the tap and getting through that thick piece of steel. So how tight is this tap going to be again in the chuck? Let's have a look. I don't want it to drop on the steel there. Well, just really, there we go, it's loose. So literally just with 2 fingers coming loose. Absolutely no problem at all. That's really, really nice. This is a 10.5mm drill bit, and it does go all the way through. So we are going to try and completely tap that hole all the way through. So let me get this all chucked up and let's see if it's able to do it. Now, while I do this, the power tapping that I normally do with this machine, the drive motor that I've installed is only really strong enough to tap up to M8. So I'm not actually too sure if it's going to be able to tap M12. But we're going to try and we're going to see what happens anyway. I think the worst that can happen is that the belts either slip, well, just really the belts slip, or the motor stalls out. I don't think we're going to break this 12mm tap. And then also just to show you what's happening here, I've got some marks on the tap itself. So where are they? There they are actually. They were in the front there. I have measured how far this tap goes into the chuck. So when it is chucked up properly, this lower black mark here is where the teeth go down to, or the jaws, they go down to this section over here, and then they go up to this section over here. The teeth don't actually touch the bit from this section up to the top here. Well, at least when it's clamping this size shaft. Now, also another thing that these guys recommend, I think I remember reading this in the catalog or somewhere on their website, that they say when you're using a tap, then you must cut off the square drive off the top of the tap and then clamp it into your chuck. Now, I'm not going to do that. I think it's pretty stupid. I'm not going to waste my tap like that, because then I can't manually use this tap anywhere else. So I'm just going to stick it in like this and we're going to see what happens. I also did found that they say whatever bit you're putting in here, you must put in at least 2/3 of the bit into the chuck. So I've taken some measurements here. As I said, those are the two, that's where the jaw clamps. And this distance between the bottom line, the bottom black line and the top black line is about 24 millimeters. And it happens to be that the square drive ends here, and the distance from the bottom of this bottom black line to where the square drive starts, that is 16 millimeters, and the rest here is 8 millimeters. So what is that? Yeah, that is correct, 8, 16, 24. So that happens to be 2/3 that it is gripping from the bottom line up to this section here. So that should be correct, or it should be sufficient according to what they claim. So I'm just going to chuck this up. Okay, there we go. Well, let's try and get those lines to the front there. I don't know if you'll be able to see it from where you are, but we'll pop that in like that. And again, how tight am I going to make this? Well, I'll see if I can show you. I'm not going to do excessive tight. I'm just going to go to where the ratchet ends. So holding the top, and that's it. That's where the ratchet ends. And again, I'm going to put a little black line. Let's see if we can, let me just advance this quickly. There we go. We'll put a little black line on the tap here and a little black line on the tooth. Oh, it's not really coming out on the tooth. I think there must be oil on there. Anyway, there's a little black line underneath here. Hopefully you guys can see that. Now, I can see in the viewfinder here that it looks like they are misaligned, but I can tell you they are not misaligned. What I'll do, once we've tapped the hole, if it does slip or doesn't slip, I will get you looking in square on this line, and then we can have a look at what happens. So let's try and see what happens here. Also just going to put some cutting fluid on here, Tap Magic #1. Let's put a whole lot of fluid on there. Okay, dripping all over the place. Wonderful stuff. And let's see what happens. Okay, so you can actually see it did slip, and it looks like it's tightened itself up. There we go, it's slipping some more. Tightening, I would assume, and then it's continuing to go. There we go, the belt is slipping, so I'm just going to stop. So yeah, I suppose the limiting factor now is the belt drive that I've got at the top there. I'm not really going to make it any tighter. That's the whole point of the belt. The way it is, it's a little bit of a safety. So let's just see if we can reverse it and try again. Break the chip, and let's try it again. Nope, I can hear the belt slipping. So that is not going to work. What we might have to do is head over to the lathe and pop it all into the lathe, where I know there's definitely going to be enough power, and then we'll continue the tapping there. I thought I would give this another go. So this is a tapping test using a brand new M12 by 175 tap in a 10.5 millimeter hole drilled in this piece of cold rolled steel. Now this is spinning at 30 RPM, and you're going to notice that the tap is about to slip slightly, and then it grabs again, and it goes a little bit further before letting go and then continuing to slip. And here I'm backing out the tap slightly before trying again. And once again, it starts slipping. Now, to be fair, and I also kind of mentioned this earlier, in one of their videos showing tapping with this chuck, they do say to cut off the square drive at the end of the tap, so the jaws have maximum surface area to grip onto the tap. And I didn't want to cut the square drive off any of these taps because this is a brand new tap. Now, I do also have a M14 and an M16 brand new tap. These are expensive taps, and I'm definitely, just to do some testing, not going to cut off the square drive on the end, because after the testing I can't use them manually anymore. Now maybe cutting off those ends would have made all of the difference, or maybe no difference at all. I'm not so sure. And just to check if the tap was jamming up in the hole, yeah, I've just removed the same tap from the chuck and I've put it into a manual handle, and I'm going to tap this hole the rest of the way through by hand, just to gauge how easily or difficult it is to actually tap. And you can see that nothing is binding up, and I'm easily able to tap the hole all the way through. So to wrap up, what are my thoughts? Well, so far I am really liking the chuck. I've only had it for 2 weeks though, so just keep that in mind. But for the drilling operations, as we could see, up to 20 millimeters in mild steel, absolutely no problem. It was really easy to tighten and to loosen after the operation. When it came to tapping though, again, M8 tap into mild steel, absolutely no problem. But stepping up to M12, we did see the tap slipping in the chuck. But please keep this in mind though, the company does recommend that you cut the square drive off the end of each tap. I didn't do that, so maybe my tapping tests were not sort of really fair, a really fair test of this chuck and its capabilities when it comes to tapping, especially those larger diameters. So I do have some critical thoughts. What are those thoughts? Are these chucks, given its complexity inside, is it user serviceable? Because, you know, as we know, if you go and buy something like, I'll bring it up again, an Albrecht, really expensive chuck, that's like $500 or $600. But those are fully serviceable. You can get a service manual for them, you can get spare parts, you can get everything. And I think this is of concern because, I mean, you could buy a chuck and keep it for 10, 20, 30 years. So it would be nice to have a service manual for this thing, and I wonder if it is actually user serviceable and if you can get spare parts. I'm not too sure. Maybe if this FODBITS company is watching this, they can leave us a comment and let us know what is all available. So how long is this chuck going to last? Well, I mean, I would love to know as well. I've got absolutely no idea. I've only had it for about 2 weeks now, so your guess is as good as mine. Maybe you've already got one of these chucks and you've been using it for a long time already. Please let us know in the comments, share your experience with the rest of us, and maybe we can all learn something. If you haven't got one of these and you are interested in buying one, I was just about to say I'll leave a link, an Amazon link in the description. I need to still go to Amazon to check if they are actually available on Amazon. I don't know. I probably should have done that research before this. But if they are, I will leave an affiliate link in the description. And if you want to support the channel, please go ahead and use that link to buy. You know, I'm sure all their products will be there. I hope. But please don't be forced or pressured into buying this. Absolutely do your own research and buy whatever chuck is going to best suit your needs, whatever brand that might be. And I can't remember if I mentioned this earlier in the video, but there are two sizes of this chuck. This is the 13 millimeter, and you get a slightly bigger one, which is a 16 millimeter chuck. And I think it can drill up to, I think it is 24 mils in mild steel. Now, I don't have that chuck to show you guys to test, but maybe if I ever get my hands on it in the future, I don't know, maybe the company decides to send me one of those chucks. I'll do some basic testing and also probably share that with you guys. Anyway, if you found this long video useful, please give it a thumbs up. I really do appreciate you if you've made it this far into the video. Let us know in the comments what you think about all of this. It's always really great to hear from you. As always, I'm going to ask you to subscribe, but you know what? I would really appreciate it if you kind of swung back around and maybe went and checked out some of my other videos. I do have another video from a few years ago where I reviewed another brand of keyless chuck, so maybe go and check that out. I'll see if I can link it somewhere up here. Otherwise, there's a lot of other DIY and tool related review videos on the channel. It would really mean a lot to me if you kind of swung around there and watched a couple of those, and let us know in the comments what you think of those videos. Otherwise, thank you very much for watching, and we'll see you next time. Cheers.